Hello my dears, very good morning to all. So in the last class we discussed about the analysis of AC circuit. That is nothing but what happens when AC is passing through a resistor or an inductor or a capacitor, right? And we started deriving the equation for power, right? Instantaneous power as well as the average power in a resistive circuit and in an inductive circuit. Okay, now we are going to derive the power equation for capacitor. Power in a capacitive circuit. So we already derived the equation for power, average power for inductor as well as a resistor, right? So in a capacitor, we have the equation of what? V of t, that is equal to Vm sin omega t, and I of t is nothing but, what was I of t? It was Im sin of omega t plus 90, right? That means current is leading the voltage by an angle 90. That was the capacitive circuit, right? That was, we already derived that, right? We already derived that in a capacitive circuit, pure capacitive circuit. The current is leading the voltage by an angle 90 degree. So we can say that the instantaneous power, right? Instantaneous power small p is equal to instantaneous value of voltage into instantaneous value of current, right? The instantaneous power will be nothing but instantaneous value of voltage into instantaneous value of current, which is nothing but, I can write like p is equal to, what is instantaneous value of voltage, which is nothing but Vm sin omega t, right? And what is instantaneous value of current? It is nothing but Im sin of omega t plus 90 degree. Is it correct? Is it correct? Or I can write like Vm Im sin omega t into sin omega t plus 90 is nothing but, what is that? Cos omega t. Is it correct? Sin omega t is 90 is nothing but cos omega t. I can write like that. So which is equal to nothing but Vm Im. See, I am going to multiply the equation with the 2 and 2, right? In the previous case, I multiply and divide the equation with the 2. Then I will get Vm Im, right? Vm Im by 2, Vm Im by 2 into 2 sin theta cos theta. What is that? 2 sin theta cos theta. What is that? I already mentioned it is nothing but sin 2 theta, right? So sin 2 theta, sin 2 theta. So this is the instantaneous power equation. This is the equation for instantaneous power. Then what will be the average power? What will be the average power? Average power capital P is nothing but, average power capital P is nothing but, what is that? 1 by t integral 0 to t into small p of t, right? Instantaneous power dt, right? That is the average power. Or V of t into I of t dt is nothing but, okay, that's also you can write. So see, which is nothing but 1 by t integral 0 to t into, what is that? Vm Im by 2 into sin of 2 omega t d omega t, right? D omega t, it is d omega t. It is d omega t because time period is no 2 omega, right? So it's the omega axis, right? So it will be 1 by t integral 0 to t, or simply 1 by 2 pi integral 0 to 2 pi, that also you can use, no issues there. Vm Im by 2 into sin 2 omega t d omega t. I already mentioned that whenever we are dealing with the average value, whenever you feel some waveform, it is symmetrical in nature, right? Symmetrical in nature. Then the average value will be, of course, here. You can integrate by yourself in your home. 0 to 2 pi sin 2 omega t will definitely see, no doubt there. Okay, so you can say that the average value here, which is nothing but 0. Average value is nothing but 0. Or we can conclude that for a resistive circuit, whenever we passing some alternating current or voltage through a resistive circuit, then the average power developed is nothing but, what is that? Vrms into Irms, right? For resistive circuit it was, for R circuit it was Vrms into Irms, right? Vrms into Irms. And for L the average power was 0, and for C the average power was 0. Is it correct? Is it correct? which means what you infer from this, or what you conclude from this derivations. The conclusion is that only the resistor has the capacity or the capability to dissipate the power, dissipate the energy in the form of heat, sound, or anything, light or anything you may see. But in the case of inductor as well as capacitor, it doesn't have the capability to dissipate power. It doesn't have the capability to dissipate power in the form of heat, light, sound, or anything. Then what did it do? It simply do a thing that it simply do what? It absorb it store the power for some half cycle or positive half cycle, say it will be positive half cycle, and for negative half cycle I already explained that what inductor and capacitor do means, for positive half cycle it may store some amount of energy, and for negative half cycle, if the polarity is reversed across its terminal, whether it is inductor or it is a capacitor, if the polarity is what happens is the polarity is reversed. Consider the case of inductor. See, if they charge this inductor, suppose this is an AC means, if they charge this inductor, but positive half cycle, this will be the polarity. For negative half cycle, the polarity will be reversed. That means the magnetic field will collapse. The magnetic field become collapsed, and what happen? It will release the energy which is absorbed by it. That is happening there. In the same case, in the case of capacitor also, whenever we give some voltage, alternating voltage to the capacitor, that is why for an AC circuit, for an AC voltage or current, the capacitor doesn't charge. The capacitor doesn't charge for AC. The capacitor will only charge for DC, not for AC. Because continuously its polarity waving, continuously its polarity is varying. So for positive half cycle, it may store some charges in its plates. But for negative half cycle, what happened? The same charge it start releasing. The same charge it start vomiting. In other words, it vomiting the same charges. That means there is no storage of charges in a complete cycle across a capacitor, or there is no energy in a complete cycle in the case of inductor. Correct. So inductor as well as capacitor, there is no capability. It doesn't have the capability to dissipate power in the form of heat, light, sound, anything in the form of anything. But only resistors can do that work. Resistors can dissipate power, or resistors can dissipate energy in the form of useful manners, like light, like sound, like heat, anything. Is it clear? That is the conclusion that we obtained from this analysis. I hope it's very clear to you. Okay. And one more thing you have to notice here, that there is one more conclusion from the analysis, that for resistive circuit, for resistive, we can say that V in phase with I, right? V in phase with I. But for inductive circuit, for L, what was that? I lags behind V by 90 degree. And for capacitive circuit, for C, I leads V by 90 degree. This is thumb rule. No? This you have to always keep in your mind. This is very important. This is you have to always keep in your mind, that for resistor V in phase with current, for inductor I lags behind V by 90 degree. These all are pure elements. Okay, this is the assumption that is all are pure elements. Okay, for pure inductor, for pure resistor, for pure capacitor. I again mention it's pure. It's assumption. We can't made a pure resistor, made a pure inductor, made a capacitor. It always contains some combination of resistor, inductor, capacitor, inductor, capacitor, like that. But for pure resistor, V in phase with I, for pure inductor, I lags behind V by 90, and for pure C, I leads V by 90. This data is very important. This is a very funda data for, because it is continuously we are going to use in continuous classes, right? In further classes we are going to continuously use, or we are going to play continuously with this concepts. Okay, so that's all about the part AC through R, L and C. And let's now going to discuss what happens when AC is passing through an RL circuit or an RC circuit or an RLC circuit, right? Or an RLC circuit. Or an RLC circuit. Or an RLC circuit. Okay, so let's discuss AC through RL. AC through RL. AC through RL. Okay, consider an RL circuit. Okay, consider a RL circuit which is energized by V of t, which is nothing but M sine of omega t, okay, which is an AC circuit. Okay, which is energized by an AC voltage which is equal to Vm sine omega t, and see, this is R and this is L. VR is the voltage which is developed across the R, and VL is the voltage which is developed across L, right? VL. Okay, and we know that let I of t be the current, right? Let I of t be the current. Let I of t be the current. Simply represent it as C. Okay, then we are going to analyze the circuit. Okay, we are going to analyze the circuit and we are going to derive some important definition, important fact from it. Okay, so please focus the subject, focus the circuit RL, and we are applying V of t, I of t. Is it okay? Okay, then we know that I took see, suppose what will be the phasor diagram? What will be the phasor diagram? See, suppose this is VR. I am taking this VR as reference, and we know that in a resistive circuit, I mean, suppose we deal with the resistive circuit, the nature of the resistance is in such a manner that it always drag a current, let be I of t, which is in phase with the voltage, right? The resistance we already discussed now. In the last class, in the last session, we already discussed now. In the pure resistive, V and I in phase quantity. So VR and I of t what in phase quantity. In the case of inductor, what happens in the case of inductor? I can write like, see, this is VL. Is it correct? Is it correct? Because in the case of inductor, the current is lagging behind the voltage by 90 degrees. Is it correct? The current is lagging behind the voltage by 90 degrees. Is it correct? Correct. So this is the phasor diagram. Okay, and if two vectors act like this, then definitely there will be a resultant. Definitely there will be a resultant, and that resultant is nothing but V. That is nothing but this V of t. That is nothing but this V of t. And this is always making an angle phi. This is always making an angle phi with reference to the I of t, or with reference to the x-axis simply. Is it correct? Is it correct? So I can say that, see, the same figure, no, this same figure, the same figure can be equivalent to, this is equivalent to VR, VL and V. Is it correct? The same figure is equivalent to what? This figure, because this VL is taken to this side, this VL is taken to this side. It's my wish now, whenever I can place my vector. So I place here. So VR plus VL will be equal to V. So I can say that vector VR plus vector VL will be equal to vector V, right? Vector V. Vector VR plus vector VL is equal to vector. These all are vector, right? These all are vectors. These all are vectors. Or I can say that V will be, magnitude of V will be equal to VR square plus VL square. Is very, very important. It's very important. Because in an RL circuit, suppose you give some value V, there is a drop of 5 volt. You can't say that simply this is 50 volt and there is a drop of 5 volt means the remaining will be 45. You can't say like that, because it's all are vectors. Because we are dealing with imaginary quantities now. It's not pure resistor circuit no. So we are dealing with imaginary quantity. So there will be some vector action. So that is why, see, we can't say that it is not simply VR plus VL equal to V. It's vector VR plus vector VL equal to V, or modulus V equal to, that is the magnitude of V will be equal to what? Root of VR square plus VL square. Is it correct? So I can say that this VR, no, this VR. Okay, this is the phasor diagram. Next I am going to draw the impedance diagram. Impedance diagram. Listen carefully. So this is VR, no. This is VR, no. And this is of course VL, no. And this is V, no. This is V, no. This is phi and this is V. What is VR means? It is nothing but I into R. Correct. VR is the drop across this resistor, which is nothing but I of t, or simply for the simplicity I represent I, simply I into R, right? I into R. And what is VL? VL is nothing but I into XL, right? I into XL, right? VL is nothing but I into XL. The same current I of t into XL, inductive reactance, will give the value VL. That is the voltage drop across what? Inductor. Voltage drop across inductor is nothing but current across the inductor into inductive reactance. That is mean by what? I into XL. Is it correct? And I can say this V is nothing but I into Z. I into Z. Where Z is called the impedance. Where Z is called the impedance. Why it is so impedance? Because in an RL circuit, we can say that it is a resistive circuit. It contains resistor plus inductor. So the combination of resistor plus inductor is always represented like, or resistor plus capacitor is always represented like impedance. Impedance, right? Impedance. So this is I into Z. The common factor here is I know. I into Z, I into XL, I into R, all will be I know. So I can replace this I know. I can simply vanish my I. I mean, I can simply rub my I. I can simply rub my I, right? Rub my I. What is the remaining fact here? What is the remaining fact here? R, XL and Z. Or I can say that Z will be equal to root of R square plus XL square. Is it correct? Mod Z, right? Mod Z will be equal to root of R square plus XL square. And what is the value of cos phi here? What is the value of cos phi here? What is the value of cos phi here? Cos phi is equal to, I can write like R by Z, correct? Cos phi is nothing but adjacent side by hypotenuse, no? Adjacent side by hypotenuse, no? So R by mod Z, right? R by mod Z. Because cos phi is an angle, no? It is a pure value, right? It's a raw value. So cos phi is equal to R divided by mod Z, not the vector Z. So cos phi is equal to R by Z. It is called the power factor of the circuit. Power factor of RL circuit. It's very important. So power factor of RL circuit. Power factor of RL circuit. Okay. Got the idea? Got the idea? Okay. So this is the impedance diagram. And let's see what is the, I will explain what is the meaning of power factor in the next session. I mean the preceding section. Okay. Not preceding, in the continuing section. So what is, see, next we have to see power diagram. So now you got, first you simply draw the what? Phasor diagram, which connecting V and I and all. Then you extract the voltage from that and you go for impedance diagram and you go for power diagram. Okay. There is a, why this flow is happening means in the continuous circuits this flow is same. First phasor diagram, impedance diagram and next power diagram. That's why I explain. So I can say like, see, this is my VR, right? Which is nothing but I into R, right? VR is nothing but what? I into R, right? So I will write I into R, and this is nothing but VL is equal to I into XL, right? And this is nothing but what? V is equal to I into Z, and this is phi, I am going to multiply all the three sides with I. What I get? I square R, I square XL, I square Z. I square R, I square XL, I square Z. Then I can't say this is VR. I will say this is P. Now I can't say it is VL because it is multiplied with I. I will say Q. Now I can't say this is V. I can't say this is V. I will say this is S. See how easily we are going to derive some facts now. When I was a student in my electrical classes, this was a long session for us, and this was very boring for us, because there was no continuity and there was no logic in choosing some parameters like. But I found myself what is the simplest way to deliver this content, and I found this way: multiply with, divided with, remove with, that simple concept. Then I myself found this way. Okay, I think it will be very easy for you to. It will be very easy for you to, because for remember this concept, these tricks may very much helpful to you. Otherwise, it will be very boring. Otherwise, it will be very laggy and lengthy. It is not at all interesting to you. That's why I found my own way to derive all these things. Okay. So in your textbook, there are different method or different ways to solve all the things. You may follow that also. It's up to you. This is my way of deriving all the things. Okay. So this is P. This P is called the active power. This P is called the active power, and this Q is called the reactive power, and this S is called the apparent power. This S is called the apparent power, or we can say that S is equal to root of P square plus Q square. S is equal to root of P square plus Q square. Then from this, can you tell me what is cos phi? What is cos phi? Cos phi is nothing but P by S, correct? Active power divided by apparent power. So this is the definition which is most important in this session. Cos phi is equal to active power by apparent power. Cos phi is equal to active power by apparent power. So I already said to you that when I deal with cos phi is equal to R by Z, I will explain the impact or exact feeling in the continuous session. That is this. So what is the meaning of cos phi, or what is meaning of power factor in a circuit? So power factor means it is a ratio of active power to the apparent power, which means usually in my classes, when I was a student in MTech, my teacher was used to say an example of active, apparent and reactive power. Like, I don't know whether it is as a star or as a lecturer, can I repeat or not, I don't know, but I will tell you. Beer, I think all of you familiar with the beer, at least you might have tasted, or someone is there, you definitely don't taste at least beer, so at least you saw in movie, right? So beer, suppose you took a glass of beer, suppose this is beer, because that was wonderful example for finding what exactly active and reactive. So when you pour some beer on glass, this is glass, right? This is glass. So when you pour some beer on glass, right, it will be like this, it will be like this. Up to this there is beer, up to this there is beer. Just pardon me if I am violating my ethics, okay? Because beer and all, no need to take an example, right? I know it is actually not ethical, but let's enjoy the class, right? Let's enjoy the class, So this is a beer. So up to this, you can say that this is a beer, and you can always see that this is a froth, right? Froth. This is the froth of beer, froth of beer. Okay, and this is the beer, right? This is beer. This is beer, right? This is beer. So if you take a glass of beer, so until this point, no, up to this point, it is that yellow liquid, right? So before that, there is froth always. There is froth always. Is that froth is drinkable? Is that froth is drinkable or no? Of course. We remove the froth and we only drink the beer, no? We only drink the beer, no? So that drinking portion, no? See, the whole is the apparent power. Yes. The whole is the apparent power. Yes. That drinkable portion of beer is the active power. And that froth portion is the reactive power. That froth portion, no? This portion, that froth portion, no? That is the reactive power, I will say. That froth portion, no? That is the reactive power. This is the concept of power factor. So power factor is nothing but active power to the apparent power. That means from the power that we given to a circuit, that is called the apparent power. That is called the apparent power. That apparent power is nothing but the total power that is we are given to the circuit. From that power, only certain power can do a useful amount of work. A useful amount of work. That may be in the form of heat, in the form of light, in the form of sound, in the form of anything, in the form of smell or anything. So a portion of the power that we are given to the circuit only capable of doing a useful work. But there is always some quantity of power which is not useful directly. That means which is not utilized as a useful amount of power. That power is called the reactive power. The total power that we injected into circuit is called the apparent power. And the amount of power which is directly converted into useful amount of power or useful amount of work done in the form of heat, no? Suppose we are giving some voltage to a resistor, it will heat up, right? So that heat is called the active power. That heat is called the active power, right? And the total power is the apparent power. Useful power is the active power. The power which is directly take part into the useful work, take part in the process of useful amount of work is called the what? Reactive power. Reactive power. Then what is the use of that reactive power in a circuit? What is the use of that reactive power in a circuit? See, in a transformer, say in a transformer, it's a very deep concept actually. In a transformer, no, there is primary as well as secondary winding, no. So we are giving some amount of power as apparent power to the input, and we will get some output, right? Of course, we will get some output, and there is some heat in the form of heat, and there is some output also. Okay. So the useful power we obtain is nothing but the output is obtained in the output obtained. Suppose we are connecting some light, no, bulb here, it will blink, right? It will blink. So there is some useful amount of power conversion, and of course the core of the transformer may get heated up. So the core heated up component plus the lighting component, all together we can say useful what component of power. But there is some power which is associated with the linkage of the circuit, no? Here it is a flux and here it is a flux. There should be some linking point, no? That linkage is actually responsible for the transfer of power from one circuit to another. That power is called the reactive power. Or we can say that reactive power is nothing but it is the driving force of the active power, or which is the carrier of active power. No, the role of the reactive power is that it has to carry the active power from one point to the active power to the load side. So that medium or carrier is called the reactive power. It's a very deep concept actually. It's very deep concept. No, as for competitive examination view, it is not deep. It is not needed very deeply. No, it's not need that much deeply. But for your information, I am saying. So simply you can take the concept of beer also. Beer. The total content of the beer, that means the liquid froth is called the apparent power. The drinkable portion, that means we get the useful amount of work done, no? Suppose we drink the beer, you will get some kick or something like that. So that is the useful amount of work. Whether it is useful or not useful, say it is useful, okay? So that is called the active power. and the froth portion, no, froth portion which is not usable, but we can't say it is a beer means there should be some froth, no, that is called the driving force or the driving power. So the reactive power is always the driving power of the circuit, or media or the connecting link of the circuit, in order to transfer one form of power to the source to the load side. So see, I am a reactive power means here it is some active power, I have to give that active power to the side. So me act as a medium or me act as a reactive power. Then only I can drag the active power and I can give it to the load side. That is a simple way we can explain the concept of active, reactive and apparent power. Is clear? So cos phi is, suppose the value of cos phi, the value of cos phi may vary from, cos phi value vary from 0 to 1, cos phi value vary from 0 to 1. What it means its maximum value of 1, which is not possible all the time, it's not possible any manner, because for ideal concept only cos phi is equal to 1. That means whole of the power that we given to the circuit is converted into useful power. It's not possible all the time. Even if you take a pure resistor which is made by mankind or ourselves, definitely there the cos phi value will be 0.98 or 0.99 something. We can't get cos phi is equal to 1 because it is an ideal case. So cos phi is equal to 0 to 0.5. Suppose cos phi is equal to 0.5 means, 50% of the power that we given to the circuit is converted into useful amount of work done. That is the meaning. 50% of the power that is given to the circuit is converted into the useful work done. That is the meaning of cos phi is equal to 0.5. Then what is the meaning of cos phi is equal to 0.8? 80% of the power that is given to the circuit is converted into useful amount of work done. Bus. Is it clear? So that is the meaning of power factor. Or there is some equation for power, all powers also. We will explain now. We will write now. Okay, we will write now. See, from this diagram, what is cos phi? From this diagram, what is cos phi? It is nothing but P by S, no? P by S, or P is nothing but S into cos phi. S is nothing but simply Vrms into Irms, or simply V into I cos phi. So P is equal to what? Vi cos phi. P is equal to what? Vi cos phi. And from this diagram, what is sin phi? Sin phi, it is Q by S, right? Q by S, right? From this diagram, sin phi is equal to Q by S, no? Q by S. Then what is Q now? S sin phi, or which is equal to Vi sin phi. Is it correct? So P is equal to Vi cos phi and Q is equal to Vi sin phi. And simply S is equal to what? Simply V into I. S is equal to what? Simply V into I. So we can say that what is the unit of this Vi cos phi? We can say that it is in watt. It is in watt. So active power is nothing but in watt. Active power is nothing but in watt. Then what is Q? It is a reactive power now. So we can say that its unit will be volt ampere reactive. Its unit will be VAR, or simply volt ampere reactive. So its unit will be what? VAR. And what is S now? It is simply apparent power now. Apparent power is nothing but voltage into current, simply voltage into current. This is RMS value. Okay, remind all the time, this is RMS value. Okay, so RMS value voltage into RMS value current. So it is nothing but volt ampere. This is nothing but volt ampere. So that is the concept of powers: active, reactive and apparent power. I think it's very easy, whenever you feel the subject and whenever we feel the content, it is very easy. It's very easy. At the same time, if you start by heart all this, it will be hectic. It will not be all the time in your mind. It will vanish slowly after some days, after some week or two. It will not be useful. It is like a reactive power. It is like reactive power, not usable actually. We need active power, no? We need active power all the time. Okay, so that's all about the concept of active power, reactive power and active apparent power, and the very important thing, that is the power factor. Very important thing, that is the power factor. And what is the unit of power factor? What is the unit of power factor? See, the numerator also in power means we can say watt like content, no? Watt like content. So numerator as well as denominator, both are power terms, right? Both are power terms. So cos phi is a unitless quantity. It's very important. Cos phi is unitless. But sometimes we can, we can say like cos phi is equal to 0.5 lag or lead. Like that you can say. 0.5 lag or lead, that's how you can say. 0.5 lag means it's an RL circuit. That means there is an influence of more inductive component, right? Cos phi is equal to lag means there is an influence of inductive component, I will say. Suppose cos phi is equal to lag, then it means that of course it will be an inductive predominant circuit. Or the dominant factor will be the inductor. That's why it is a lag. Suppose cos phi is equal to lead means it is capacitor or capacitive predominant circuit, capacitive predominant circuit. Or cos phi equal to unity means it is pure resistor. Cos phi is equal to unity means it's pure resistor. So lag means it is inductor, lead means it's the effect of capacitor is much there, and unity means there is a pure resistor. There is no phase angle between that, no. See, cos phi is nothing but, see, one more thing I will explain. Cos phi is equal to R by Z, or which is nothing but P by S, no. You can say like that. What is phi here? Phi is nothing but the phase angle, or the angle between voltage and current, right? Or V and I. Cos phi is nothing but the power factor, phi is nothing but the phase angle, that is the angle between voltage and current, right? In the previous diagram and all, you will know, in the first Phasor diagram you can see that the resultant voltage and the I of t angle. The angle between resultant voltage V and I of t is the what? Phi, right? In the previous figure, no, here it was a figure, no, that figure reflect that, okay? It is the phi is nothing but phase angle, the angle between voltage and the current bus. So that's all about the what? AC through RL. And that's now we are going to discuss what will the effect of AC through RC. AC through RC. AC through RC, okay? AC through RC, right? So simply I can write V of t and I of t. See, this is an RC circuit and we are giving a similar voltage, no? V of t is equal to, we gave an input like V of t is equal to Vm sin omega t, and this is R and this is C. VR is the voltage across resistor and Vc is the voltage across capacitor. Then what will be the Phasor diagram? Okay. What will be the Phasor diagram? See, I can again take this reference value, right? VR as a reference value. Definitely we know that there is a in phase quantity I, no, I of t, or simply I. There is an in phase quantity. That means this current is in phase with the resistor, no? In pure resistive circuit, the current and the voltage will be in phase, no? That is why VR and I in phase. And we know that for a capacitive circuit, the current I will be leading the voltage by an angle 90. Is it correct? So it will be downward direction, no? In previous case it was there because the voltage was leading the current, or the current was lagging behind the voltage by 90 degree, right? But in a pure capacity circuit, we know that the current will be leading the voltage across the capacitor by 90 degree. And if there is VR and VC, of course there will be some resultant voltage, and that resultant voltage will make an angle phi with the reference or x-axis. So this is the what phasor diagram. I will modify this phasor diagram to simple manner like, see, this is VR and this is VC, this is V, this is phi, this is VR and this is VC and this is V, okay, and this is phi. So that is called the voltage simply phasor diagram. Then what will be the impedance triangle? What will be the impedance triangle? Okay, let's see that. So I can say that this is VR, no, this is VR, no, this is VC, no, and this is V, no, and this is phi. So VR is nothing but what? I into R, right? I into R. VC is nothing but I into XC, right? And V is nothing but I into Z, right? So what is common here? Here I is common to all three sides of this triangle, right? So I can eliminate that I. So we can say that it is V. I can eliminate this I. So we can say that it is VC. I can eliminate my I. We can say that is VR. What is remaining there? What is remaining there? Only R, XC and Z. R, XC and Z. No? Then what is cos phi here? What is cos phi here? Cos phi is equal to nothing but what is that? R by Z again. No issue there. Cos phi is equal to R by Z again, which is called the power factor of the circuit. This is called the impedance triangle. This is called the impedance triangle. Or we can say that Z is equal to, that is mod Z is equal to root of R square plus XC square, right? R square plus XC square. Is it correct? Is it correct? Or what will be power triangle? What will be the power triangle? We can say that, see, this is VR, no? VR I can write like I into R, right? I will say like VR is equal to I into R, and VC is nothing but I into XC, no? And V is nothing but I into Z. I am going to multiply all the three sides with I again. What will happen now? I square and I square. So that I can't say this is VR now because it's I multiplied with I know. I can't say that it's VC now because I multiplied no. I can't say it is V because I multiplied. But I can't say this I square R is equal to P, I square X is equal to Q, I square Z is equal to S, I square Z is equal to S. That is the power triangle of an RC circuit. That is a power triangle of a RC circuit, right? So I can say that here also, from here also I can say that P is nothing but VI cos phi, and Q is nothing but VI sin phi. What? Volt ampere reactive, and S is equal to VI, or simply volt ampere. Simply volt ampere. So that is the power triangle. Or from here also I can say that S is equal to modulus S is equal to root of P square plus Q square. Root of P square plus Q square. Is it clear? Is it clear? Okay, let's check my time now. Let's check my time now. Okay, time is there. Time is there. Okay. Is it clear? So that's all about the AC through RL and AC through RC. And let's discuss now what is AC through RLC. What is AC through RLC? if you know the first step, you may feel some difficulty. If you grab the content or concept, if you grab the concept, then the things will be very easy. You can continue for long time the same procedure, that is very easy actually. So AC through, next we have to see AC through RLC circuit. See, this is an RL circuit, this is a RLC circuit, right? This is a RLC circuit. So that V of T is the current, voltage, and I is the current, RLC, VR, VL, VC, you know all this, you know all this. So there are two possibilities, that first one, let's take the voltage drop across VL is greater than VC. First case 1. Say it is case 1. Then what will be the phasor diagram? What will be the phasor diagram? Let's see that. So we know that again, this is VR and this is in phase with I. I and VR are in phase quantities. For an RL circuit, we know that this is VL. And for RC circuit, we know that this is VC. Is it correct? RC circuit, we know this is VC. Is it correct? Okay. And it is mentioned that VL greater than VC means the length of this vector, VL vector, it will be higher than that of VC vector. That is the meaning of VL minus VL greater than VC. The length of this VL vector is greater than the length of the VC vector, and the same figure you can translate to this is same as see, this is VR, this I can say VL minus VC. That means which is nothing but I took this VC from below to upper side. That means if two vectors are at opposite direction, if two vectors are acting opposite direction, then the resultant will be the difference between two. You know that. If two vectors are acting opposite direction means the resultant between the difference between that, right? The difference between that. That means VL is here. You can take VC upper side so that it will be minus VC, minus VC. So VL minus VC will be a single vector which is represented by this single vector VL minus VC. And due to this VL minus VC and VR, there will be a resultant V, and that resultant will make an angle phi with the I. This is the concept of what VL greater than VC. And what happened when case 2, it is VL less than VC, VL less than VT. Then what will be the phasor diagram? VL less than VC, what will be the phasor diagram? I can say like this. So this is my VR, suppose this is VL, and this will be VC now, because VC is greater than VL, and this is I. This can be again simplified like this is VR and this is of course I, this is VR and this is of course I. This can be taken to the side, which is nothing but VC minus VL. And there is a resultant of V here. And this wave is phase and angle phi. That means if VL less than VC means it is predominantly the dominating factor here will be the capacitance. If VL greater than VC means the dominating factor will be the what? Inductor. That is why the current is still lagging the voltage by some angle. Lagging means it is something what related to inductor. But in the case of VL greater than less than VC means it is predominantly in the case of a capacitor. That means the dominating factor here in the circuit will be the capacitive nature. So that it always, see, the current is always leading the voltage with some angle phi. So the leading means, current leading means it is something which is associated with the capacitive effect. The current is lagging means, with respect to voltage, the current is lagging means which is something with respect to the what? Inductive circuit. So it will be more inductive. It will be more capacitive. It will be more capacitive. It will be more capacitive. Is it clear? Let's check my time. Let's check my time. Okay. And we see, so this is the concept, right? This is the concept. I think AC through RLC is clear to you. So there are two possibilities where VL greater than VC or VL less than VC. Then what will be the impedance here? Impedance. So in an RLC circuit, the impedance Z may be written like mod Z is equal to R square plus either XL minus XC the whole square or XC minus XC the whole square, depending upon what? Depending upon the magnitude given. Whether XL is greater, it will be XL minus XC the whole square, where XC is XC minus XC the whole square. Anything you can interchange, because square will be what? If even though it is negative, the square will be positive, no? So there is no meaning in writing XC minus XL or exactly XC minus XL or exactly XL minus XL. XC. There is no meaning in writing like that, because square will always cancel the negative sign, no? So no issue here. So that is the impedance, right? That is the impedance. So in an RLC circuit, the impedance will be root of R square plus XL minus XC the whole square. Or what is the V? The resultant voltage V here, which is nothing but VR square plus VL minus VC or VC minus VL the whole square. VL minus VC or VC minus VC the whole square. Again, there is no change in cos phi and all. Cos phi is nothing but R by Z. Cos phi is nothing but R by Z. Is it clear? So these things now you have to keep in mind. So that's all about the AC through RLC circuit. See, from these sessions, one word question you may expect. Like in an RLC circuit, if XL greater than XC, then what is the nature of the circuit? Or in a pure inductive circuit, what is the nature of voltage and current? Whether it lag between current or whether it lead between voltage and current, no? What is the phase angle in between those two? Like that, the questions you can expect. So next we can see the very important concept, resonance. It's a very big topic actually. I will start now and we will continue. If it's not completed, we will continue in the next session. Okay. So resonance in RLC circuit. So this is RLC circuit, right? There is a current flow I. Okay. So the condition resonance means whenever in a series RLC circuit, the condition for resonance is when XL is equal to XC. The condition for resonance is nothing but when XL is equal to XC. That means the inductive reactance will be when the inductive reactance will be equal to capacitive reactance. Then that is called the resonance condition. That is called the resonance condition. That means when XL equal to XC, what will be the voltage? V. We know that V is nothing but VR square plus VL minus VC the whole square, right? VL minus VC the whole square. Or I can write like VR square is equal to I into R the whole square plus VC is nothing, VL is nothing but I into XL minus it is I into XC the whole square. Or I can like write like IR square plus I into I square into XL minus XC the whole square. If XL equal to XC means this term will not be there. That means there is only I into R the whole square. Or I can say that V is equal to simply I into R, or I will be equal to V by R. That means whenever XL equal to XC, that is the condition of resonance. So at that time V will be equal to this like, so that I will be equal to V by R. So initially if resonance doesn't happen, then what was I initially? I is nothing but V by mod Z. So compare it with this, I is equal to V by R. Of course Z will be equal very much greater than R, no? Z will be very much greater than R, no? So at the resonance condition, the current will be maximum or minimum? The current will be I V by R, but here is V by Z. So this parameter, this I will be higher than this I. So at resonance, how can I say at resonance, current will be maximum. At resonance, current will be maximum. This resonance circuit you can see in your tuning mechanism, tuning, radio tuning and all, no? Suppose you tuned for some value, then at that time the current will be rush or maximum, so that you can select your channel. You can select your radio channel and all. Okay, where you can apply the resonance, no? Resonance. In tuning mechanism or tuning, channel tuning, etc. you can use that resonance. So at the resonance, current will be maximum. Where we can see a resonance in practical case. No? Suppose we increase the volume of our TV, then what happens means the vibration of what window will happen, no? There is a vibration of window will happen. That means the glasses of the window, no, starts vibrating. How? Because the sound, no, we are increasing the volume of sound, no, that sound has a natural frequency. Whenever that frequency is matched with the natural frequency of the glass, then the maximum amplitude will happen. That's why that glass, no, starts shattering. Like that, resonance is a condition of maximum amplitude, maximum current, like that. Okay. So at the resonance, current will be maximum. Or we can say that at the resonance, impedance will be minimum, no? Impedance will be minimum. Impedance will be minimum. At resonance or series resonance, right? If series resonance happen, at the series resonance, current will be maximum, and resonance at series resonance, the impedance will be minimum. Okay. What's the time? Okay, time is up. So some more thing is there regarding resonance that we will continue in the next session. Okay. So today, thank you for all. Please revise the subject carefully. Please continuously revise it. Okay. Otherwise, it will be slowly it will be forgot from your mind. So please continuously start revising. Okay. And don't wait for 6 months is there, 1 year is there. You can't cover it for for all electrical subject 2 months. You can't cover it for, within a span of 2 months you can't cover it. At least you take 7 to 8 months in order to deeply study the subject. So please start prepare from now itself, because soon after the corona and all, there is a possibility of conducting electrical inspectorate exam. It's a super job. One of my friend is there as a assistant electrical inspector. He joined as assistant electrical inspector. Now he's, I think, 3-4 years now. See, he will be in very good post now. He is in very good post now. So he's my close friend actually. So it's a super job. It's a super job and very respected job. So there is an exam for probably within 2 or 3 months. The exam will be there for assistant electrical inspector. It's a glamorous job. So please try for that, okay, and please start study from now, okay. Don't wait for the last moment or yet to the confirmation to be happen, no. Yet after confirming the exam, I will start reading or start studying. It's a blunder actually. It won't work. So start from slowly start from now itself, and always try to keep in touch with the subject. Now at least 1 hour per day you have to keep in touch with the subject. Then only there will be a friendly relationship between you and electrical. Then only it will work. Otherwise it will be familiar. No, it's a stranger for you. No, it's a stranger for you. So don't wait for that time, at least, and at that end time. You start from now itself, okay? You can start from now itself. So that's all for today. So let's see again, okay? Thank you so much.